Look at this page. For centuries, philosophers assumed a newborn's mind entered the world exactly like this. This tabula rasa, or blank slate, suggests infants arrive with zero built-in knowledge, meaning every mathematical principle must be painstakingly written onto the brain. Modern neuroscience, however, has started mapping the active systems of the infant brain, revealing a reality that contradicts the blank slate theory. These pages are not empty. They come with an invisible structure, a pre-installed operating system designed specifically to handle quantities. The human mind never starts as a void. It arrives equipped with a biological toolkit designed to decode the physical universe. Biologists call this hardware numerosity. It is the innate ability to recognize and compare quantities without ever actually counting them. You don't need language for this. If you show a 6-month-old 2 sets of objects, their eyes will naturally track the larger group long before they learn the names for numbers. This isn't a vague feeling, it has a physical location. Deep in the cortex is the intraparietal sulcus, the brain's dedicated number module. This region activates automatically. When you look at a cluster of trees or a pile of stones, this hardware fires to estimate the volume instantly. We didn't learn this behavior in a classroom. We inherited it through millions of years of human evolution. Understanding basic quantities is a biological trait, as built in as our sense of sight or our ability to breathe. This raises a difficult question. If we are all born with a number module, why is mathematics famously difficult for so many of us? The difficulty lies in the difference between our natural sense of quantity and the symbolic world of equations, algebra, and calculus. Symbolic math is a very recent cultural invention. It is complex software that we are attempting to run on ancient biological hardware. There is significant cognitive friction involved when we try to translate a wordless feeling of more or less into abstract, rigid symbols. Struggling with a math equation doesn't mean your brain is missing a component. It simply means you are doing the hard work of translating biology into culture. Let's look at this page one more time. Given what we know about our biological hardware, we must reevaluate what this white space represents. This isn't a void of ignorance. It is a specialized canvas, pre-formatted to handle the specific data of our environment. The frustration you might feel when learning new math is the sensation of writing new code onto that ancient foundation. Because that foundation is shared, our capacity to build upon it is vast. We can continue layering abstract concepts over our innate instincts, using that biological base to reach into higher levels of logic, physics, and engineering. The pages of our minds were never blank to begin with. We arrive with the foundational architecture of the mathematical brain already in place, the starting point for every calculation we will ever make.